All right, sorry, I got a late start on recording this. I just forgot. So what have we done so far? Here's a this is what they tell you. They tell you the length is pink length right here is 10, right? And we want to find the area of this thing. So I drew a line here, which is the apothem, and then I'm trying to find the perimeter. So what I've done here, the reason I drew all these other lines is because I wanted to show you that there's 1, 2, 3, 4, 5 triangles in here. I take 360 divided by 5. Each of those angles, this one, this one, this one, this one, this one, are all 72 degrees. All right, I don't need those lines now. That was just there to get you to understand why I took 360 and divided it by 5. That gives you that big angle right there. That big angle is 72 degrees. But I'm not really concerned about that whole entire angle, am I? I just want the one inside that right triangle. Okay, that one right there. Because remember, this is an apothem, so it's perpendicular to that side. So if the whole thing is 72, how do I find this little one right here? Divided by 2. So 72 divided by 2 is 36. So that angle right there is 36 degrees. Now look, I got a lot of stuff all drawn in here. You don't have to do this, but sometimes this is helpful. I'm just going to redraw this without all the junk around it. Okay? So there's that. That's the A. That's 10. And this is 36 degrees. Alright, so far it hasn't been all that difficult. What have we done? What math have we done so far? We just went 360 divided by 6, or 5, sorry. 360 divided by 5. And then I took that angle and I divided it by 2. It's the only math that I did. A couple little division problems. No big deal. So now what do we want to do? We want to find the apothem. Now look, I understand we might have not done exactly this problem yesterday in class. But I kind of expect you to remember things from what we've done in the past. So what are you going to use? You got a right triangle. You got an angle. This is adjacent. This is hypotenuse. What are you going to use to solve for A? The sine. The sine. That's right. I kind of expect you to remember stuff that we've learned in the past. So it's the sine of the angle.
Mr. Hemrick, can I see Jake Fraley, Blake Noonan, and Brett Netzer for a minute in the office, please?
Okay.
Thank you.
Middle class, okay. Alright, so the sine of 36 is equal to the adjacent over the hypotenuse. Actually, it's not sine. Where are we getting sine from? Sine is what? Sine is opposite over hypotenuse. Is this the opposite?
Should we do cosine? No.
We should do cosine, shouldn't we?
Yes.
Yeah, why did I listen to him? Okay, we're not doing the sine, we're doing the cosine. This is adjacent over hypotenuse. So we use the cosine of 36 degrees. All right, so the cosine is equal to adjacent, which is A, over the hypotenuse, which is 10. Multiply both sides by 10. This is why we learned stuff before, so we can use it again. And now you just put all this in your calculator, and you have what the apothem is. So let's put that in a calculator. It's 10. Let's clear all that stuff. Let's try it again. 10. Oops. Try one more time. There we go. 10 cosine of 36. There you go. 8.09. Let's round it to one decimal place. So what's that round to? 8.1. So let's go 8.1. That's the apothem. Did we really care about the apothem? Absolutely. Because look, that's part of our formula that we wanted to find, isn't it? So what are we going to put right here? 8.1. So we're halfway finished, aren't we? That wasn't that bad, was it? It did take a little bit of thought. So what did we have to do? We had to find the big angle, which is 72. We had to find this one right here in the right triangle, which is half of that, which is 36. Then we just had to go adjacent over hypotenuse, which is cosine. And you've got the apothem. But now we have to find the perimeter. Well, in order to find the perimeter of this thing, I need to find the length of one of the sides. Now, I really need to find that whole length right there, but look at my triangle. From here to here is not the whole B, is it? We'll call this something else. I don't know, call it X. Is that all right? So we got to find this little side right here. It's not that hard. We got our right triangle, got an angle, got a hypotenuse. What can we use now to solve for X? Look at this angle, look at this side, look at this. This is the hypotenuse, this is opposite. What trig function uses opposite and hypotenuse?
Sine.
The sine, that's right. The sine of the angle. So it's the sine of 36 equals the opposite, which is x, over the hypotenuse, which is 10. Multiply both sides by 10. So now we just plug that into the calculator. So it's going to be 10 instead of 10 cosine. Oh my word. Oh, what's going on? Oh, that was crazy. Why did it do all that stuff? I don't know. Let's try it again. 10 sine of 36. There we go. So what's that round to? Yeah, let's use 5.9. So x is about 5.9. That's that right there. Now, is that what the whole... That's not the whole perimeter, is it? What is that? That's not even the whole length of one side. What is it? It's just half of one, right? So this is, what I say was 5.9? So that's just that. I could double it and get all of b, couldn't I? So what do I do? I'd have to multiply it by 2 to get this side, and then multiply it by what to get the whole perimeter? 5. Or I could just take 5.9 and multiply it by what? By 10. Couldn't I? If I want to do it all in one shot, you could do it. You could do it times 2 and then times 5. That's perfectly fine. You could do that. It's no big deal. I just looked at it and say, wait a minute, I can just go times 2 times 5. That's the same as times 10. So what's 5.9 times 10? So the perimeter would be 5.9 times 2 to get the whole side, then times 5 to get the whole perimeter. So it's 5.9 times what? 10. Do that in your head without a calculator. What's that? 59, right. It's a 0, right? Multiply by 10, move the decimal place one place. So the perimeter is 59. We're just about finished. So that's what we're going to put in for the perimeter. You put a 59 right there. One more thing. Throw it into a calculator. That's all you got to do. Chuck that into a calculator and you got the area and you're finished. So it's half of 8.1 times 8.1 times 59 equals, did I do that right? 8.1, 59, yep, 238.9, or the 9 rounds that 8 to a what? To a 9, that goes to a 0, so let's just say 239. So 239. It would be 0.0 if we rounded it to the 10th. That right there is the area of that pentagon. It's 239. Hey. Does it make sense? So, is it just one step and you're done? Absolutely not. I mean, there's quite a few steps to this. But every step you should be able to do. There's really nothing in here that's really all that difficult that you can't handle. Let's go through it quickly one more time. What do? We find the angle, right? 360 divided by how many sides we have? That's 72. We cut that in half too because we just want to find that angle inside this right triangle. That's 36. Use a trig function. Use the cosine to solve for a. We did it right here. Then let's solve this bottom right here. Call it x. Let's use the sine to solve for x. We find that. Right? What do you do with that 5.9? Multiply it by 2 to get the whole side. Then multiply it by 5 to get all 5 sides. It's 59. Multiply all that stuff together. Bang. There's your answer. It's not so bad, is it? Let's do another one. Is it bad?
Yeah, that's exhausting.
Well, get used to it. That's real math, okay? This is not baby math anymore, okay? We're not in Algebra 1 anymore. All right? This is, you got to start thinking that working a problem is going to take more than just 1 or 2 steps. And I think it's kind of fun. I kind of enjoy doing all those steps to get the final answer. Let's do this one right here. Let's do number 3. So this is how many sides? 1, 2, 3, 4, 5, 6. So it's a hexagon. I think I have a hexagon sitting over here. It's right here. And what? What is that? What is that? 6. Can you wait till after this problem is over? Good. Here we go. Let's pay attention. Hey. Show me that you really apologize by not saying anything anymore then. Okay? No. I just got done saying. Show me that you really apologize by not saying anything anymore. That would really show that you're sorry. Look at this. Now, they drew this thing so that it looked like this. About like that, didn't they? They made it look like that. But it's the same thing, right? So I'm just going to keep it like this. I think I like this better. What do? They give you the apothem, don't they? They say that's 6. This is what they give you, and they ask you to find the area.
So the apothem 6?
Yes, the apothem is 6, because they tell you the apothem. So yes, the apothem is 6.
Wait, you don't have to write 6. You that's not
Okay, we just discussed this. I appreciate you paying attention. I said it was twisted around with the point up like this. I said, but I kind of like it like this a little bit better. It's the same exact shape. Okay, it's just twisted around a little bit, and that side right there went to went to the right. Right, it was kind of twisted, went to the right. I like it like this, just because I like the bottom of this triangle being nice and horizontal. It's the only reason I did that. It's just for the looks. That's really all it is. It's just for the looks.
I didn't know.
So watch what we're going to do. We're going to do the same process as what we did earlier. We're going to draw here, and we're going to draw here. So that should be automatic. When you do these problems, that's what you should be drawing right there. What's the next thing we want to find? Is that angle. So how do we find that angle? It's 360 divided by, it's not 5 this time, is it?
6.
It's 6 because there's 6 sides.
So wouldn't the angle be 60?
So that would be 60. So this whole big angle right here is 60. But I'm not really concerned about that whole entire angle. I mean, I need it, but I need it because I'm going to do what to it?
30,
I'm going to cut it in half, and so that's going to be 30 right there. Okay, this is a right angle, so that means this is going to be 60 right here. So let me do this. Again, you don't have to do this, but sometimes this is easier. It just kind of clarifies things a little bit without all the stuff written around it. You understand why I'm drawing this separately?
Yeah.
Just to kind of get it out of all the junk, okay? So what do we have here? We got this as 6. We have this as 30 degrees. We have this as 60 degrees. And that's all we know, isn't it?
The hypotenuse is
Do we know the hypotenuse?
no, but
Not
it's
yet.
square root of 2 times.
Well, let's do this. What are we trying to find? Do we really care to find the hypotenuse? Because remember what we're doing. We're going area equals 1/2 what? Times the apothem times the perimeter. Well, look what they gave us. We didn't even have to figure it out. They told us the apothem. What's the apothem? It's 6. So what we have to do is find the perimeter. In order to find the perimeter, we're basically at the same spot as we were in the last problem. So in order to find the perimeter, I need to find this side right here. We'll just call it x again. That's what we called it earlier. You could use a trig function at this point if you wanted to. Okay? Or, right, you could use tangent. Right, the tangent of 30 is x over 6. You could use that, and that would be fine. Okay? I wouldn't have a problem with that at all. It's a completely legitimate way to do it. But since you have a 30, 60, 90 triangle, I think it might be a little easier, I don't know, to figure out what this is. I could figure out what x is without really doing any math. This is the short side, this is the long side. So how are we going to find the short side if I know the long side? I'm not going to multiply it by the square root of 3. I'm going to do what? Divide it, because this is a smaller side, isn't it? So I'm going to take 6, you're right, divide it by the square root of 3. So that's what that length is. That's what this is right there, 6 divided by the square root of 3. But what am I trying to do? I'm trying to find the perimeter. So I could multiply it by 2 and then multiply it by 6, or I could just take that and multiply it by 12. So watch, let's just stick it right here. So 6 divided by the square root of 3 times what? 12. Right? You could just write it like that. And then you could do all that in your calculator. Everybody see that? So you could plug in all that stuff in your calculator and see what you get. Half of 6 is 3. Well, you could do half of 6, but let's do this. This half of 6 is 3, right? Let's just put it all in a calculator. I don't want it too much in your head, okay? So 1/2, that's 0.5, right? Times what? 6. Times what? 6 again. What's on the top here? 12, right? So times 12. And then divided by what? Square root of 3. Square root of 3. And then, there you go. 124.7. 124.7. And that's the area. That was actually pretty easy. Because they told you half of it right there, didn't they? They told you the apothem. You didn't have to figure out the apothem. And the other problem, look, the other problem, you didn't know the apothem or the perimeter. You had to find them both. In this problem right here, they told you the apothem. So that's half the battle right there. All you had to do is find the perimeter. So to find the perimeter, you had to find the length of this little segment right there. And then you multiplied it by 2 to get the whole side, multiplied it by 6 to get the whole perimeter, and that's where we got the 12 from. You understand where we got that 12? Because it's times 2 times 6. 2 times 6 is 12, so I just multiplied it by 12. Is that making a little bit more sense?
Yeah.
Okay, let's look at another one. Yes, you can. Take that pass, please. Let's do one of these. I'll blow it up a little bit here. Let's do this one right here. And let's get a little bit of, let's go red. If I wanted to find the area of this figure right here, what I'm going to do is I'm going to split it up. Actually, let's make that a little bit thicker. See that? Look what I have. What do I have? I've got this, which is a rectangle. So how do I find the area of that rectangle? I'll put R for rectangle. Yeah, so give me some numbers.
12 times 5.
Right, which is
4.
about 60. Okay, that's 5, that's 12. So this right here is 60. Everybody see that? What else do I have? I got a triangle. And it's a isosceles triangle, isn't it? Now look, so how do I find the area of, I'll put T for triangle. How do I find the area of a triangle? 1/2 the what? The base times the height. Do I know the base of this triangle? I don't? It's not 60, no. Yeah, let me get rid of the 60. The 60 is the area of that rectangle. Yeah, this base, this red line right here is the base of this triangle, isn't it? Okay, so it's 12, right. It's the same thing as this right here. So that is 12. So let's put what we know in there. 1/2 the base, which is 12, times the height. Do I know the height? Is the height 20? No. The 20 goes from here all the way to here, doesn't it? All right? That's not what I'm finding. I'm finding from here to where? To there. All right, so that's what I'm trying to find right there. And let me go back to there. And so what is that? How'd you get 15? 20 minus 5. That's right, because look, that little bit's 5, this little bit's 5. All right, so what is it? It's 20 minus 5, and so that is 15.
So all you really need to know is like
That's right. All you need to know is the formula. The rest is kind of common sense, isn't it? All right, you just got to figure out what the lengths, what the certain lengths are. A little subtraction, a little addition, whatever it takes. Okay. So what is the height of this thing? It's 15. And then there you go. You just do the math, and you got it. Half of 12 is 6. 6 times 15 is what? 90? Is it 90? I think it's 90. Yeah. And so that would be 90. That's the area of that thing. Oh, I'm sorry. That's just the, I shouldn't circle that. That's just the triangle. Yeah, yeah. That's just the triangle. So I got to take the 60. Tell you what, let's not circle. Let's put it in a box. I leave circling for my answer, okay? So the rectangle is 60. The triangle is 90. What do I do to get the total area? Or the total, actually, let's not say circle. Let's just say the total area is what? 60 plus 90, which is 150. All right, and so that's the area of that whole entire thing right there. Now look, I'm not going to go through every single step on this next part because I'm going to get, we actually have some time and you can work on some of this in class. Let me just go through and give you some hints on it, okay? So let's take a look at this and see some hints. What do I have here? What do I don't have a rectangle and a triangle. What do I have?
Circle.
Yeah, it's not just a, it's a semicircle. That's right. So it's how much of a circle? How much of a circle is this? It's half, okay? So how? What do I need to find the area of a circle? I need the radius, don't I?
Pi r squared.
Okay, but I need the radius.
So that's all things 3.
What's the radius? Is the radius 3?
2.5.
1.5.
How about 1.5?
Jeez.
Okay. Okay, so the radius is 1.5. So how do I find the area of the circle? Pi r squared, right? Now that's a full circle. So what do? Take half of it, right? That's a semicircle. So I'll let you plug the numbers in. I'm just giving you some helpful hints here. What about this thing right here? That's not hard. It's a triangle. What's the base of the triangle? Right? It's 1/2 the base times the height. So what's the base of this triangle?
3.
It's 3. What's the height of this triangle? It's 7. That's right. Because look, it goes from here, and it goes. Well, that was supposed to be. Oh, I'm sorry. From here to here, right? We'll call that. Make it a little thicker. There we go. All right. So that right there would be the height, and it's 7. So it's pi r squared over 2 plus 1/2 the base times the height. I mean, is it like you have to memorize this particular formula? No. You memorize the area of a circle. You memorize the area of a triangle. You just look at it and see that you've got to put those together to find the total area. It's not too hard, is it? Let's look at this one. This one looks kind of crazy, but it's not near as hard as what you might think it would be. Oh goodness, gotta do this. It's a crazy looking shape, but watch what we can do with it. What do you think we can do with this?
Make it a square.
Make it a square. Make it a square how?
Connect the two.
Connect from here to here. That's right. Everybody watching this? Now look. Look what I did. I made it into a square. I got 8 and I got 8. But what am I going to do with this stuff? Yeah, that's a semicircle. But then what am I going to do after I find the area of the semicircle? Subtract it. That's right. We're not adding it, are we? We're taking it away from that whole square. So what I do is I find the whole square. Again, I'm not putting numbers in. I'm just trying to give you some hints. So how do I find the area of this whole square? It's the base times the height. That's the whole entire thing. But I got to take away this stuff right here because that's not part of the shaded, is it? All right. So I got to take this away from it. So I got to subtract what? Pi r squared. Now it's a half a circle, so what do? Divide that by 2. Everybody see this? This right there is the square, and this right here is the what? It's the semicircle, right? It's a half circle, but we'll call it semicircle. Okay? Everybody understand that? That's not so hard, is it? It looked kind of crazy at first. What's the radius of this semicircle? It's 4, that's right, because all the way across is 8. So from here to here would be 4. So look, I've given you everything you need to know. It's just plug and chug now. Make sense? We'll do one more, then I'll let you get started on these and the other side as well. So look at this. I've got 3 different things I need to find the area of. All right? You don't have another side?
No.
I only gave you one side?
Some of us already finished it.
Did I give you 2 sides?
No, there's only one side.
Nobody? What? Well, I'll get you your other side. All right? Because it should be 2 sides. All right, let's look at this. So first of all, let's find this. This would be a rectangle, wouldn't it? So how do I find the area of a rectangle? Base times height. Look at the base. That's easy. 30. What's the height of this rectangle right here?
15.
It's 15. That's simple. What about this thing right here? That's a semicircle, isn't it? So it's going to be what? Pi r squared, what? Divided by 2. So the thing is, what do you got to find? You got to find the radius. What's the radius of this semicircle? That's right. It's half of 15, which is 7.5. To tell you the truth, watch this. Consider this. You could take half a circle to get this and then do the same thing over here, or you could just do what? I almost hate to even say this because some of you guys will freak out over this. I could just say go pi r squared because that would include this and this, wouldn't it? Because if I took this, picked it up, stuck it right here, I would get a circle, wouldn't I?
You're just showing us the pi r squared?
All right, forget I said that. All right, what's that? You got to put the numbers in. Yeah, you got to put the numbers in and get real numbers.
But the 30 is showing just for the rectangle, not the side. It's not going all the way
Right.
to the end.
Yeah, it's from here to here. Right, it's just a rectangle.
So you're adding that. You're not subtracting it.
Right. There's no subtraction. It's this
You gotta
plus
add
this
in-
plus
you gotta do
this.
that twice because you got to add it both sides.
Right, so you're going to go watch. What you're going to do, you're going to go base times height, that's the rectangle, plus pi r squared over 2, that's this, plus another
Yeah.
pi r squared over 2. Now watch what I was trying to tell you. All right? Forget it. No, I'm tired of it. I'm really, really tired of you not paying attention. So I'm not going to show you that. That's good enough right there. So plug the numbers in yourself, and you'll be good to go. All right, I'm going to get that other half for you. No, you're going to hang on to this. Finish what you couldn't do before. All right? So all these right here, I don't think I did this one, but look, this one right here, if you look on YouTube from last night, the example I did in class was just like this, okay, when I gave you one of the sides. All right, so you look on YouTube or you look at your notes, okay, whatever it takes. I did one just like that yesterday in class. All right, so be a big kid, be a student, look at it on your own, and that'll show you how to do that. Do all these, plug in all the numbers, see what you get, and do the second page as well once I get it to you. All right, I'll be right back with your second page.